Welcome to section 1.6, multiplying and dividing fractions. You can multiply or divide any fractions. No common denominator is necessary. Now, unless you like reducing large numbers, cross-cancel before multiplying straight across. And it's very important for you to keep in mind that cross-canceling only works for multiplication. So again, cross-canceling only works for multiplication. So to divide two fractions, what you're going to do is flip the second fraction then multiply. And this is what we mean when we say multiply by the reciprocal. And we do mean the reciprocal of the second fraction. So multiply by the reciprocal of that second fraction. Let's take a look at a few examples. So here, in example 1, we have example 1 is 3/4 times 6/7 or 6/7. Now we could multiply straight across first, or we can cross cancel. So let's look at this as multiplying straight across first. So that would be 3 times 6, and in the numerator we would get 18, and then 4 times 7 in the denominator would give us 28. But that's going to require us to reduce, right? So we can reduce here. Both of these numbers are divisible by 2, so 18 divided by 2 gives us 9, and the denominator 28 divided by 2 gives us 14, and we can't reduce anymore. Now, if we cross-cancel, do the same problem, cross-canceling, it looks like this. So cross-canceling means we're going to be looking across, right, to say like 6 and the 4. 6 and the 4, right? Where we're saying 6 and 4, 2 is a multiple of each of those, so we can divide by 2 for each one. So 6 divided by 2 is going to give us 3, and 4 divided by 2 is going to give us 2, so we can reduce it by 2. So we can multiply across now, and we have 3 times 3 is 9, and 2 times 7 is 14. So we can get to that reducing in the same number of steps, but now we don't have to worry about multiplying 4 and 17 and also 3 and 6 in that numerator. And then we're just going to use cross-canceling for example 2. So here we have 5a over 12 times 42 over 65. So I don't really want to have to multiply 5 times 42 nor 12 times 65. So let's do some cross-canceling. 5 and 65 are multiples of or have factors of 5. So we'll divide each by 5 and we get 1. And in the numerator for that first number we have 1a, and the 65 can be reduced to 13. 65 divided by 5 will give us 13. And then 12 and 42 both have factors of 6. So 6 is a factor of both 12 and 42. So 42 divided by 6 leaves us with 7, and 12 divided by 6 is 2. And now we can multiply across. In the numerator for the first fraction, we have 1a. So 1a times 7 gives us 7a. And in the denominator, we have 2 times 13, which is 26. So that, in example 2, our answer is 7a over 26. And the same thing follows in the next Example 3 here, we again are going to do cross canceling, and it doesn't matter where the cross canceling takes place, but we have to make sure that it matches, right? So here, for instance, 9a and 3b, 9 and 3 have common factors. So we're going to look at those as cross canceling. So we can reduce 9 to 3. 9 divided by 3 is 3, and 3 divided by 3 is 1. And the 15 and the 10 will cross cancel there. And so both have factors of 5. 10 divided by 5 is 2, and 15 divided by 5 is 3. But let's not forget about the variables. We have here a variable a squared in the denominator for that second fraction, and we have the variable a in the first fraction. So what we can do here is we can cancel out one of the a's. So this a is gone, and we can reduce this down to a. But let's look at everything again and make sure we've canceled everything down as much as we possibly can. And no, we haven't, because look, we have in the first fraction, we have a 3 in the numerator and a 3 in the denominator. So we actually can cancel this down to 1, both the numerator and denominator. And what we're left with in our numerator is 1 times 1 times 2. So the numerator is 2. In the denominator, we have 1 times 5a times 1 times 1b. So that would leave us with 5ab as our final answer for example 3. Now example 4, we're looking to multiply. And remember again, to multiply two fractions, what we're going to do is flip the second fraction, then multiply. So then that means we will rewrite this as 14 over 3 times 9 over 7. We're flipping that second fraction or multiplying by the reciprocal. So here we could do some cross canceling so that we could reduce and not have to multiply by 14 times 9, right? So cross canceling this, 14 becomes 2 and 7 becomes 1 because that factor is 7 for both the 14 and 7. And then 9 and 3 can both be divided by 3, so 9 becomes 3 and the 3 becomes 1. And we're left with in the numerator 2 times 3, in the denominator 1 times 1, so that's 6 over 1, or just 6. And we want to write our final answer in simplest form, and so the simplest form here would be 6. So make sure you do write it in that final form. So we will continue on with example 5 here, where we have a complex fraction of 5a over 24b divided by 15a over 36. So remember, to divide by a fraction, you will multiply by the reciprocal. So we can rewrite this as 5a over 24b times 36 over 15a. And then we can cross cancel rather than multiplying across to get such large numbers. So we're going to cross cancel this 5 and 15. Both have a factor of 5. 5 divided by 5 is 1, and 15 divided by 5 is 3. And we can cancel the a. A divided by a is 1. And then we can cross cancel with 24 and 36. They both have a factor of 12. That's the greatest common factor there. 24 divided by 12 will give us 2, and 36 divided by 12 will give us 3. And look again, for the second fraction, we can reduce further. 3 divided by 3 is 1, so we can reduce that down to 1. And we're left in the numerator with 1 times 1, which is 1. And in the denominator, 2 times b times 1, which gives us 2b. So our final answer for example 5 is 1 over 2b. And lastly, with example 6, we have 3 fractions here, and it's okay. We just will take them 2 at a time. And remember, here we have this first fraction divided by this second one. If we're dividing by a fraction, we're going to multiply by the reciprocal. And with the order of operations, remember multiplication and division is on the same level, so we'll do them in the order in which we see it. So we need to rewrite this one as 35m over 21n squared times 27n cubed over 40mn squared times 25m squared n over 9m to the fourth. And note, I only flipped this second one because we are dividing, so therefore we're going to multiply by the reciprocal. And now with such large numbers, we definitely want to do some cross-canceling. And we'll just do the cross-canceling according to how we might group things together. And you may take a different one and group them, and it's okay. So here I'm going to look at 35 and 40 as I'm cross-canceling between the first two. So 35 and 40 have a factor of 5 in common, right? So 35 divided by 5 leaves me with 7 here. And for the 40 divided by 5 gives me 8. Okay, and now we can do some cross-canceling with the 27 and the 9 here. So 27, 9 goes into 27 3 times, and 9 goes into 9 1 time. So we can reduce that down to that. And here again, we can do the cross-canceling with 21 and 3. 21 divided by 3 is 7, and 3 divided by 3 is 1. So this will reduce down to 1. And we can do more reducing with our number here, because in the numerator for this first fraction we have now 7 and 7 in the denominator. So this can be reduced down to 1. So when just looking at the number part of this, in the numerator we have 1 times 1 times 25. So our numerical part will be 25 for the number, and in the numerator. And then in the denominator, the number is going to be 1 times 8 times 1, which is going to give us 8 for the number part. Now let's look at the variable. Let's look at the m. In the numerator, remember, to multiply exponents, we add the power. So we have m to the 1 times m squared. So we have m to the third in the numerator. And in the denominator, we have m times m to the fourth, which would give us m to the fifth in the denominator. So m to the third in the numerator and m to the fifth in the denominator. This is going to reduce down to an m to the second in the denominator. So we're going to be able to cancel out the m to the third in the numerator and just be down to m cubed. M squared in the denominator. So in our denominator, we do have that m squared. And then looking at the n in the numerator, we have n cubed times n, which would give us n to the fourth in the numerator. And in the denominator, n squared times n squared gives us n to the fourth. N to the fourth divided by n to the fourth would give us 1. So we cancel out the n. So all the n cancels out, both the numerator and denominator. So our final answer for this problem, example 6, would be 25 over 8m squared. 25 over 8m squared. That ends section 1.6.